Hey everyone, this is Will from BeerNIT.com, and what I'm going to do today is I'm going to attempt to relate some of the computer jargon, as some people would say. I want to explain what a lot of the things that you see when you go to buy computer products. You'll see, supports this many cores, this much cache, this much RAM. What do all of these things mean? When you go to buy products, I want you to understand all of what you are looking at. So I'm going to start this series off with a segment on processors, and hopefully, hopefully it'll receive favorable reviews, and I'll make some more of them. We start off with processors, and first of all, we should probably go to single and multi-core. And cores are like workers, and a worker can work on a thread. So, let's say you open up a web browser, it starts in a thread. If you open up a new web browser like Chrome, it actually opens up in multiple threads, which if you have more than one core, you can actually work on them all at the same time. So that's partially why Chrome is a little bit faster, is because the resources are divided up. If software is not programmed to take advantage of multiple cores, the only benefit that it will get from having multiple cores is the fact that it will have a processing core completely free. Now you have to think of a core like a separate processor. The only difference is it's all contained in one package and it's sharing some resources. But as far as the actual execution, it's like having multiples or multiple processors. I said multiple single-threaded applications you can run on free cores, and they can take full use of those cores. If you hear the term hyperthreading, which was back with the Pentium 4s, and it's come back with Intel's new processors, it takes the resources that a core is not using, and it actually has it's a little bit of dedicated hardware to duplicate some of the functions of a multi-core processor on a single core. So let's say you have a thread taking up 80% and you have another thread waiting to be worked on. It's actually going to stick the 20% of that resources in there in order to help you completely utilize the processor. This is maybe a little advanced for the course, but the difference between in-order and out-of-order processors. In-order processors are what you're going to find in like your cell phones and the Intel Atom, which is in all the netbooks. Out-of-order processors are your Pentium 3s, your Pentium 4s, your Core 2s, your AMD 64s. Those are all out of orders. When instructions are given to a processor, in order reads them as they are given. If it asks for something that the processor doesn't currently have, you can stall it. On the upside, if you have like actual code that you can see that the processor is reading, on an in-order processor, you can actually bust out the old math skills, and you can actually optimize it by hand. Out-of-order processors will take information they're given, and they will change the order to better suit the workload to keep the processor. It's called keeping the processor fed. The more time that the processor spends at 100% use, the more efficient it is, because it's using power whether it's being run or not. By hand, it's nearly impossible to optimize for. You almost always have to use programs to optimize for that. In-order processors are very simple. They don't put out a lot of heat. When you think of cost, the cost is in how big the processor is and how many hundreds of thousands or millions of transistors the thing is. In-order processors, very simple, very easy to make. Out-of-order processors, much more difficult to make, and they also put out more heat. That's also why the Intel Atom was made an in-order processor. Cache and memory are the same thing. Cache is fast memory that costs a lot more than the standard memory in a piece of work. So, like, let's say your hard drive, and you'll look at hard drives, and it'll say this hard drive has 8 megs of cache, or this hard drive has 16 or 32 or 64 megs of cache. And what that is there is a lookup table attempting to guess what it should preload. So when the thing is in idle mode, you're not actually pulling anything from it. It's loading up cache memory with what it thinks you're going to need, because going from the cache is very fast. Going from the actual unit is slow. Same thing happens in processors. Processors have level 1, level 2, level 3 cache, as far as it goes up and up. And the lower level number, so level 1 is the fastest, level 2 is slower, level 3 is slower. And but they're also larger. They don't cost as much in size because they're slower. So level 1 tries to load as much as it can, then it goes to level 2, and then to level 3. And the processor is also trying to guess at what you are going to be using, because if it's in cache, it's very fast. If it's not in cache, it has to go to system memory, and if it's not in system memory, it has to go to the hard drive. And now think about this hierarchy. If the processor has 3 levels of cache, so the memory, your system RAM, could be considered level 4 cache. It's extremely slow compared to level 3, but there's a lot of it. If you don't have what you want in memory, it's got to go to the hard drive. And when it goes to the hard drive, it checks the cache. If it's not in the cache, it goes back to the physical data. These are all fallbacks to where the data is, and the whole optimization process is attempting to keep as much relevant data closer to the execution unit, which would be the processor. Video memory on a video card serves the exact same purpose. It's working on it. It's loading polygons and working on them. And if you run out, it's got to go back to system memory, which you lose frames per second. So you can't play a game if it goes too low. Pipeline is not something you're going to see on a store shelf or anything. Where you're going to see it is on review sites. Let's say you're this processor's in this machine and this other processor's in this machine, and they cost about the same. Which one do I want? And if you go and actually look up processor reviews on Ars Technica or Tom's Hardware or something, you'll actually see things talking about pipelines. And the Pentium 4, back when it came out, had a long pipeline, and it's good at executing code faster. It takes a long time to load. And what a stall is, if you saw the stall comment earlier on the in-order processor, stalls are when the pipeline gets empty, or that happens when you get a cache miss, which a cache miss is when the requisite data was not in the cache, and it had to go look for it in the slower memories, and your processor ends up being idle because it can't keep fed, so it has to stop working. And because of how long it took to load the code, and when you had a cache miss on a Pentium 4, you could actually feel it. The whole computer would stall out a little bit. It would get very, very slow for a second, and it was kind of a little bit of an unsavory user experience. Shorter pipelines, code loads fast, doesn't execute as fast as the Pentium 4 pipelines did. So if you had execution units, 2 processors, and they had the exact same speed at everything, except one had a long pipeline, one had a short pipeline, as long as you could keep the processor fed, the long pipeline would be better. But the stalls are a problem. Stalls don't really hurt the short pipelines too much, but are the optimization engines and the cache readers and the tables that they're trying to keep all the data in are getting better and better. So the pipelines are creeping up a little bit in size again, because it's much less likely to stall. And when you have more processing cores and more threads, it's a lot easier to keep everything fed without having to keep hitting the cache so much. Instead of extended instructions, what they actually do really isn't that important. What it did for the industry is a little more important. MMX, stands for a multitude of things. Intel actually says it stands for nothing, but you can look at it as multiple matrix extension, or matrix math extension. And before these came out, your math was being done in the same way you'd think of it as a calculator. Put in number, hit operation, get number, put in your other number, hit equals, take your number and store it. and then work on that later. What a matrix is, like a 2x2 matrix, is a set of 4 numbers, and you can actually do matrix operations, like from one set of numbers to one set of numbers. And instead of if you think about what this does on a calculator, if the calculator can support holding all that information at once, is you type in 4 numbers, you hit one operation, type in 4 numbers, and hit your other operation. You've significantly reduced the amount of keystrokes that you would get out similar data, and that really is what it does for processors. It doesn't make them do as much busy work and gets it right down to more of the pure math. And 3D Now was AMD's version, and it was a little better than MMX, and it got replaced with SSE 1, which was with like the Pentium 3s, and it's up to SSE 4.2 now. It helps with certain applications, and speeding up. MMX helped with like video decoding, actually being able to watch videos. That's why MMX came out. It was a multimedia extension. It was there so that watching a video didn't cripple your old PC, and it really helped usher us into the era of internet video, internet MP3s, and all that kind of stuff. It really helped drive that revolution. So now, when you look at processors and you look at like the machines you're going to buy, and you can say, am I doing a lot of multimedia work? The SSE version may actually mean something to you, especially when your software says requires SSE version this, and knowing that having a higher version of it could actually help you more. And also when you look at the differences between like the Pentium dual cores and the Core 2s, or like the Core i3, the Core i5, the Semprons and the Athlons and all this. I mean, you can actually look at that cache and say, okay, I know what this cache does. I know what the real benefit is for having these on there. In order to actually see what the actual benefit tactile number-wise is, you'll have to go to see like the benchmark sites and everything. But I hope this helps you out a little bit with as far as what the actual processor lingo means. Future ones are probably going to be more on memory and like how they're set up on the motherboard, what video card jargon means. So hopefully this helped you out. This has been Will from Be Your Own IT. Come to our video page, beyournit.com/videos or video, and you can see all the other videos we've made. And come to our forums, b/forum. There's links on our main page. It'll show you. You can come and request videos. You can come talk to the forum members. You can also go to our store page, and we have a full list of hardware repair, desktop, laptop hardware repair videos for sale. We also have a starter business course. It includes the laptop and desktop repairs, and it also includes business handouts and books to help you get started if this is a career choice you want to pursue. Thanks for watching. This has been Will. I'll see you on the forums.